I think now everyone is able to see the diagram very clearly. Let's go for the forces, various forces that are acting. The first one is what? The spring force, Kx, the weight of the block, MAG, buoyant force, show FB. In turn, what happened? The liquid, so what is this buoyant force? Force exerted by the liquid on the solid. In turn, the solid will exert a force. I think this is what you'll be missing. I'll show it here like this. Weight of the container, weight of the container. Okay, this is next. We'll show it here. This is any reading of this. So here, spring force is what will act here, and that's the reading of the spring balance. So this is D. Okay, let's write equation. Huh? Let's write all the equation. Let's first come to the block. So on the block, what are the things are there? What are the forces that are acting on the block? Band force. This is equation 1. So then what is the spring balance reading? Spring balance reading SD should be equal to Kx. And shall we write only SD here? So this is spring balance reading. Spring balance reading, you can write it. Okay, now come for this one. So now how to calculate that one? So this spring balance reading should be equal to MAG minus buoyant force. Okay, let's come for this one. What is NE? NE should be equal to weight of the container, weight of the liquid plus buoyant force. This is the reading of this meter. Weighing scale. Very simple, you can see, nothing big. So he has given all the information. Volume of, how to calculate buoyant force. Buoyant force is equal to density of liquid. So I think it's telling water, no, submerged in a beaker. Now what is the density of liquid? We don't know density of liquid. Keep it here. Volume immersed, fully is immersed into G. So from spring balance D and the submerged in liquid contained by the weight of the beaker is 1 kg. Spring balance D reads 2.5 kg. Do we know SD? Yes, we know SD. How much it is? 2.5 kg. So it should be equal to 25 Newton. Then afterwards, do we know weight of the block A? The volume of block A is 0.03. So, okay, I'll do one thing. I'll first, weight of the container we know. Okay, I'll do one thing. Let me solve it rather than just, let me solve it. No, I'll proceed like this. Weight of the container. The weight of the beaker is 1 kg. 10, 1 g. Weight of the liquid. Weight of liquid 1.5 g. Buoyant force, we don't know. How much it will read? And it reads 7.5 g. So it will be 2.5. 2.5 you remove from some 5g it will be. So what is the buoyant force equal to? 5g or 50 Newton. Okay, agreed, I think. Okay, this buoyant force, I'm going to keep it. We know spring balance, how much it will read? .5 kg. I'll bring all the calculations. I think first we do like this, no? Okay, now let's get into the calculation part. Okay, fine. So with spring balance D reads 2. So we know SD is equal to how much? 2.5 G or 25 Newton. Okay, let's get into writing equation on the block. FB plus Kx minus MAG equal to 0. We know buoyant force, and one more, FD is equal to Kx. Getting this? So therefore now what is the equation? I can write it. FB plus Kx minus MAG equal to 0. Do we know buoyant force? S. Do we know spring balance? Kx value we know. So with that, what happen? I'll get the weight of the block. So this will be 50 Newton plus 25 minus MA into 10. What is MA is equal to 2.5 kg. So mass of the block we know. So now we know volume. So this should be the density of the block, sigma you call it. Density of the block into volume given 2.5. Volume is almost 0.003. (2,500 kg per cubic meter). Okay, after getting the density of the block, what is 7.5 kg? Balance, spring balance E, no, any 7.5 kg, no. Okay, I got the density of block here. Not needed. Okay, density of liquid we have to calculate. How to calculate density of liquid? Shall we take help of again the buoyant force only? So what is the buoyant force? So buoyant force is equal to how much? 50 equal to density of liquid.
Sir, mass of block is 7.5.
7.5 kg Newton, what happened will become 75. No, that's what I just said. No, you look at all calculation. 50 Newton, 75 equal to 10 plus 15, 75 G, not gram, G it is. Okay, now density of liquid, we can calculate volume, we know 0.003 into 10. 50 by 0.03. 5,000 by 3 kg. This one. This is the density of liquid. Now, what will the each balance will read if block A is pulled out of the liquid? When block A is pulled out of the liquid. So I'll go for a very rough diagram. Why we need density of block? For that purpose only I just calculate. So there's a part A of the problem. Now come for part B. So when I remove all, the spring balance will read is actual weight. Okay, there's a thing. So now next, what about the beaker? Beaker will read only these things. By 3. Okay, yeah, thank you. Yeah. Now you can see this. We have a liquid. What are the forces that will be acting? The forces that are acting is any dash, I'll write it. Weight of the liquid, weight of the container. That's all. No? So there's no block is there. So then in this case, what is any dash? Any dash should be equal to weight of the liquid plus weight of the container. Say this question is very important. The buoyant force. So this FB. Usually what happens, students will miss this FB. You'll go wrong. What is this FB? Force exerted by the liquid on the solid, by the solid on the liquid. So in every problem, make a practice of showing FB on the block, by the liquid on the block upward, by the block on the liquid will be downward. So without this FB, what happens? The things are totally different here. Mass of block A is 7.5 kg. It's not a gram. G is 10 meter per second square. Or I think buoyant force FB plus Kx should be minus mag on the block. This is on the block, no? Oh, you mean to say this calculation, huh? This will come 7.5 kg,
Yes, sir.
not 2.5, huh?
Yes, sir. It's not 2.5, sir. It's 7.5.
7.5. Oh, 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 oh. Okay, this is, I think now, how much it will be, ma?
Sir, even that thing will be 7,500 by 3, sir.
75 by 3, 25 will come. This 3 I'll remove.
2500.
2500,
Yes.
yeah. What will be the reading? Reading of this should be equal to mag. I think now you need mag. Okay, fine. Yeah. So this is on the block. Okay, now so it's some simplest observation, nothing big. So buoyant force is just what? Net force exerted by the liquid on the solid directed vertically. Finish over the rest all everything, the basic thing what we apply. These are some typical questions what you have. The only thing is, I shall tell you one thing. The only difficulty is what, like this FB, what you miss it. Always keep in mind Newton's third law. Action, reaction, this action, this will be reaction. They'll be equal and opposite. I'll scroll down. Anybody? Density of liquid? Anybody? Density of liquid?